Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Pyridinium chlorochromate, PCC, is a mild oxidizing agent that converts primary alcohols to aldehydes and secondary alcohols to ketones without over-oxidizing to carboxylic acids and without causing elimination or dehydration. Step 1. Identify the substrate. The starting material is 4-tert-butyl-cyclohexanol. The hydroxyl group is on the cyclohexane ring at C1 and the tert-butyl group C, CH3, 3 is at C4. The total carbon count 6 ring plus 4 tert-butyl is equal to 10 carbons consistent with the clue 10 carbon atom. Step 2. Identify the alcohol class. The carbon-bearing diol group, C1 of the cyclohexane, is attached to 2 other ring carbons, making it a secondary alcohol. Step 3. Apply PCC oxidation. PCC oxidize secondary alcohols to ketones. Therefore, the OH group at C1 is oxidized to AC is equal to O group, giving 4-tert-butyl-cyclohexane 1-1. Step 4. Evaluate option. Option A shows a cyclohexene contains AC is equal to C double bond with a tert-butyl group. PCC does not cause dehydration or elimination, it only performs oxidation of the alcohol to a carbonyl. Therefore, option A is incorrect. Step 5. Evaluate option B. Option B shows 4-tert-butyl-cyclohexane 1-1, a cyclohexanone with a tert-butyl group at C4. This is exactly the product expected from PCC oxidation of a secondary alcohol. The carbon count is 6 plus 4 equals 10, matching the given hint. Therefore, the correct answer is B. Therefore, the correct answer is option B.